Hey, want to see something cool? A new ice cave that's actually made of fire. Well, hold on, it's not actually an ice cave at all. More like a magma chamber with a hole in the roof that's been filled with ice. But hey, it's still pretty cool. Iceland is the most volcanically active place on Earth, with around 30 volcanoes erupting every year. But only about one or two putting on a show that we would actually consider significant. So why is this country full of volcanoes? And are these volcanoes also responsible for Iceland's cheap electricity? So here's how we got our first ever look inside a volcano. In 2021, scientists got their wish when a new volcano popped up off the coast of Iceland's Reykjanes Peninsula. This was the first volcanic eruption in the area in 75 years, and a rare opportunity to observe what happens when magma meets water. The magma that fuels the volcano comes from a magma chamber located deep below the surface of the Earth. Magma chambers are huge caverns of molten rock that exist beneath many volcanoes. They can be quite deep, reaching hundreds of meters below the surface. When pressure in the magma chamber increases, it forces the molten material to rise towards the surface through a central pipe or conduit. As the magma approaches the Earth's surface, it forms a mound, creating the iconic cone shape we associate with volcanoes. And when the pressure is high enough, the magma violently erupts out of the top. And if there's ice nearby, well, you get a fiery ice cave. But even though this eruption lasted for months, spewing lava, ash and gases into the sky, it wasn't dangerous. It happened far from any populated areas. Plus, it was a relatively small eruption. That's why it's important to differentiate between different types of eruptions, because although they all share some common features, each one has its own unique characteristics, and understanding those characteristics helps scientists keep tabs on volcanoes and issue warnings before they erupt so people can take cover. So let's talk about the scale of volcanic eruptions. Scientists rate them according to the Volcanic Explosivity Index, or VEI, which ranks eruptions from 1 to 8 based on the volume of material ejected during an eruption and the eruption height. On the low end, a VEI-1 eruption ejects less than 1,000 cubic meters of material and doesn't make it very far off the ground. On the other end of the spectrum, a VEI-8 eruption, like the one that destroyed much of the Roman Empire, is thousands of times more powerful, ejecting over 1,000 cubic kilometers of material and reaching an altitude of more than 200 kilometers. In general, the higher the VEI number, the more explosive the eruption. For instance, a VEI-3 eruption like the one at Mount St. Helens in 1980 can cause significant damage within a radius of around 200 kilometers. But a VEI-7 eruption like the one at Mount St. Augustine in 1966 can affect a much larger area, sometimes even on a global scale. Because Mount Augustine is a stratovolcano, it's a tall conical volcano formed by layers of lava and ash. By the way, its eruptions tend to be more explosive than shield volcanoes, which have gentler slopes and are made of runny lava. The good news is that Iceland isn't home to any of those supervolcanoes that could bring us back to the Stone Age. Instead, it's mostly made up of smaller volcanoes. Now we know a lot about the volcanoes themselves thanks to modern technology and satellite monitoring. But what makes these volcanoes special? What sets them apart from all the others? To answer that question, we need to dig a little deeper into Iceland's unique geology. Iceland sits right on top of the Mid-Atlantic Ridge, a massive underwater mountain range that stretches over 18,000 kilometers from near Antarctica all the way up to Greenland, and then on to the North American continent. This ridge is formed by two tectonic plates called the North American and Eurasian plates moving away from each other. And as they do, magma rises up from the mantle to fill the gap, creating new oceanic crust in the process. This is why Iceland is technically a microcontinent, growing larger every day as new magma is added to the mix. And while most of the volcanic activity along the ridge is fairly uneventful, Iceland's location means that it's right in the middle of a hot spot, so to speak. These spots are areas of unusually high volcanic and earthquake activity, and they can occur anywhere on Earth, although they don't last forever. Eventually, the plate they're sitting on moves out of the way, and the hot spot gets covered up. Now, Iceland's volcanoes are what's known as fissural, meaning they erupt along fissures or cracks in the earth rather than out of a central vent. This is due to the horizontal movement of the North American plate combined with the East Pacific rise. The combination creates compression, pushing the island upwards and causing the magma to find weak points in the crust and ooze out. That's also why most of Iceland's volcanoes are aligned in a north-south line. But not all volcanoes are created equal, and some pose a greater threat to life than others. One of the main factors that determines a volcano's danger level is its proximity to human populations. So, even though Iceland may seem like a sleepy little island with its cute houses and stunning scenery, it's actually sitting on a ticking time bomb, and it's not just the volcanoes that could blow. Iceland is also prone to earthquakes, which can trigger landslides and tsunamis. And to make matters worse, the country's emergency services are already stretched thin. Volcanic eruptions are usually preceded by an increase in seismic activity as magma moves beneath the surface, but sometimes there are no warning signs at all. All of this adds up to a potentially dangerous situation, especially since Iceland is a popular tourist destination. But thankfully, it's not all doom and gloom. There are things that can be done to mitigate the risks associated with living in such a volatile environment. For example, early warning systems can alert people to potential eruptions so they can evacuate. And with a bit of luck, we might one day be able to predict when the next eruption will occur. Until then, we'll just have to keep an eye on the rumblings beneath our feet. And speaking of luck, Iceland is one of the few countries in the world that can produce all of its energy from renewable sources, geothermal power, wind power, and hydropower. But the real MVP here is geothermal power, which accounts for nearly 3/4 of Iceland's energy production. Geothermal power plants harness the heat from the Earth's core to generate electricity. This is possible because in places like Iceland, the Earth's crust is thin and there's a lot of heat just below the surface. By drilling down a few kilometers, you can tap into this heat and use it to power turbines that generate electricity. And because the Earth is constantly replenishing this heat source, it's a sustainable way to produce energy without emitting greenhouse gases. In fact, Iceland is so committed to renewable energy that it's aiming to become carbon neutral by 2040. While Iceland's commitment to clean energy is commendable, it's worth noting that geothermal power plants are not without their drawbacks. The initial drilling and construction can be costly and disruptive to the local environment, and there's always the risk of an eruption, which can damage the power plant and release harmful gases into the atmosphere. However, these risks are relatively low, and the benefits of clean renewable energy are simply too great to ignore. Plus, geothermal power isn't just used for electricity. Icelanders also use it for heating, which makes sense when you consider that it's one of the coolest countries on Earth. Around 90% of homes in Iceland use geothermal energy for heating. It's an eco-friendly and cost-effective way to stay warm in the winter months, and it reduces Iceland's reliance on fossil fuels. So while it's true that Iceland's commitment to renewable energy is driven in part by the need to harness its abundant geothermal resources, it's also a commitment to a cleaner, more sustainable future for the country and the planet. So as we wrap up our exploration of Iceland's unique landscape, let's take a moment to appreciate the delicate balance that exists between danger and sustainability. Iceland is a place where the Earth's raw power is on full display, from its rumbling volcanoes to its geothermal wonders. But it's also a place where humans have found a way to harness that power in a sustainable way. Let's hope that other countries can follow suit and learn from Iceland's lead. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So, to all of our patrons, thank you for what you do to make this happen. If you're not a patron but you want to learn more about what that means, you can go to our support page.